So now suppose we will consider yn equals to c1 2 raised to n plus c2 into 3 raised to n plus 1 by 2. So this is given. Now again we need to replace n by n plus 1, n plus 2 and n plus 3. So now as there were two terms in the previous example, we replaced n by n plus 1 and n plus 2. Now we have three terms, so we need to replace n by n plus 1, n plus 2 and n plus 3. So this you will get n plus 1 equals to c1 into 2 raised to n plus 1 plus c2 into 3 raised to n plus 1 plus half. So again rearranging this, you will get 2 raised to into c1 2 raised to n plus 3 into c2 3 raised to n plus half. Then yn plus 2, which is equal to c1 2 raised to n plus 2 plus c2 3 raised to n plus 2 plus half, which is equal to 2 square is 4. So 4c1 2 raised to n plus 9c2 3 raised to n plus half. Again for yn plus 3, you will get c1 2 raised to n plus 3 plus c2 3 raised to n plus 3 plus half. So this will give you 2 cube is 8. So 8 c1 2 raised to n plus 27 c2 3 raised to n plus half. Now we need to take the determinant. So yn plus 1, yn plus 2 and yn plus 3. So for this, coefficients of c1 in the first row, you get 1 2 4 8. Coefficients of c2 is 1 3 9 27, and the last one is constant 1, so 1 by 2 1 by 2 1 by 2. Okay, so now this is equal to 0. We need to have n cross n. Therefore, as we had 1 2 3 4 cases, that is 1 2 3 4 terms, we had to consider up till yn plus 3. So that we got yn plus 1, yn plus 2 and yn plus 3, 4 terms in the first column. So again solving this matrix, so first you have to consider yn and multiply it with this matrix. Eliminating this row and column, you have to find matrix of this. So 2 3 half, 4 9 half, 8 27 half. Similarly minus 1 into, now eliminating this column and this row, you will get yn plus 1, yn plus 2, yn plus 3, and this one will be 3 half, then 9 27 half. Okay, similarly now the next one will be again plus, so plus 1 into derivative of into determinant of this yn plus 1, yn plus 2, yn plus 3 into 2 4 8, and then this half half half. And now the last one is minus half into, so deleting this row and column, you get yn plus 1, yn plus 2, yn plus 3, 2 4 8 3 9 27. Okay, so now you need to solve this determinant separately. So solving this first determinant, you get the value as 6. So yn into 6 minus solving this determinant. So now we'll consider that second determinant. So yn plus 1, yn plus 2, yn plus 3 into 3, 9, 27, half, 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 which is equal to, now you can take half from this third column outside, so it will become half into a determinant of yn plus 1, yn plus 2, yn plus 3, 3, 9, 27, 1, 1, 1, okay, which is equal to half into, solving this determinant you will get yn plus 1 into 9 minus 27, so it will be minus 18, minus 3 into yn plus 2 minus yn plus 3 plus 1 into 27 yn plus 2 minus 9 yn plus 3. Okay, so now this will be, if you multiply this minus 2 inside the bracket, you'll get 18 by 2 is 9, so minus 9 yn plus 1 minus 3 by 2 into yn plus 2 plus 3 by 2 into yn plus 3 plus 2 gets inside, so 27 upon 2 yn plus 2 minus 9 upon 2 yn plus 3. So this will lead you to minus 9 into yn plus 1 plus, now this will give you 20, so 24, so 12, so minus plus, so plus 12 yn plus 2 minus 3 yn plus 3. So this is after solving the second determinant. Similarly, we need to solve the third one. So it is yn plus 1, yn plus 2 and yn plus 3, 4, 8, half, half, half. Similarly, you can take half term outside. So you get yn plus 1, yn plus 2, yn plus 3, 2, 4, 8, 1, 1, 1. Okay, so now solving this, you get half into yn plus 1 into bracket, so 4 minus 8, so minus 4 minus 2 into, so it is yn plus 2 minus yn plus 3 plus 1 into 8 yn plus 2 minus 4 yn plus 3. So this we will get multiplying 2 inside, so minus 2 yn plus 1 minus yn plus 2 plus yn plus 3 plus 4 yn plus 2 minus 2 yn plus 3. So this will give you minus 2 yn plus 1 plus 3 yn plus 2 minus yn plus 3. Okay, so this is after solving the third determinant. Similarly, for solving fourth, so yn plus 1, yn plus 2, yn plus 3, 2, 4, 8, 3, 9, 27, which is equal to yn plus 1 into, multiplying this 4 into 27 minus 9 into 8, so it is 36 minus 2 into 27 yn plus 2 minus 9 yn plus 3 plus 3 into 8 into yn plus 2 minus 4 into yn plus 3. So this is what it is. Then after solving this, you get 36 yn plus 1 minus 54 yn plus 2 plus 1, 18 yn plus 3 plus 24 yn plus 2 minus 12 yn plus 3. So this will give you 36 yn plus 1 minus 30 yn plus 2 plus 6 n plus 3. Substituting the values of all the determinants in the first equation, you'll get 6 into yn minus 1 into minus 9yn plus 1 plus 12yn plus 2 minus 3yn plus 3 plus 1 into minus 2yn plus 1 plus 3yn plus 2 minus yn plus 3. So now which is equal to 0. So minus half into 36yn plus 1 minus 30yn plus 2 plus 6yn plus 3 equals to 0. So solving all this, you'll finally get the answer 6yn minus 11yn plus 1 plus 6yn plus 2 minus yn plus 3, which is equal to 0. So that's the required difference equation. Let's see one more example. So yn equals to a into 2 raised to n plus b into 3 raised to n. So as there are 3 terms, you need to replace n by n plus 1 and n plus 2. So replacing n by n plus 1 and n plus 2, you will get yn plus 1, which is equal to a into 2 raised to n plus 1 plus b into 3 raised to n plus 1, which is nothing but 2 into a into 2 raised to n plus 3 into b into 3 raised to n. Again replacing it with yn plus 2, you will get a into 2 raised to n plus 2 plus b into 3 raised to n plus 2. So this will be 4a raised to 2n plus 4a into 2 raised to n and 9b into 3 raised to n. So now you have to again form the determinant. So yn plus 1 and yn plus 2. Now the coefficients of a in the second column, you get 1, 2, 4, and coefficients of b in the third column, you get 1, 3, 9, which is equal to 0. So 18 minus 12, 6. So y into 6 minus 1 into 9yn plus 1 minus 3yn plus 2 plus 1 into 4yn plus 1 minus 2yn plus 2, which is equal to 0. So now this will be 6yn minus 9yn plus 1 plus 3yn plus 2 plus 4yn plus 1 minus 2yn plus 2, which is equal to 0. So final answer is 6yn minus 5yn plus 1 plus yn plus 2, which is equal to 0. This is the required difference equation. Next condition is y equals to an square plus bn. Okay. So now again, as there are 3 terms, you have to replace n by n plus 1 and n plus 2. So yn plus 1 is nothing but a n plus 1 square plus b n plus 1, and yn plus 2 is nothing but a n plus 2 whole square plus b into n plus 2. Now we need to find delta yn. So delta yn is nothing but, as I told you before, it is the difference between yn and its next term. So it is yn plus 1 and yn. So now solving this, you will get a into n plus 1 whole square plus b into n plus 1 minus an square minus bn. So this will give you an square, then 2an plus 2an plus a plus bn plus b minus an square minus bn. So an square, then bn. Finally you will be having 2an plus a plus b. So this is the first one. So now in the next step we'll consider delta square yn. As we have seen before, delta square yn is nothing but yn plus 2 minus 2yn plus 1 plus yn. We need to substitute the values for yn plus 2 and everything. So you'll get a into n plus 2 whole square plus b into n plus 2 minus 2 into yn plus 1 is 2 into a n plus 1 whole square minus 2b into n plus 1 plus an square plus bn. So now we can take a terms, we can take a common in this. So we have a into n square plus 4n plus 4 plus b into n plus 2 minus 2a into, sorry, we can expand this n plus 2 whole square, so we'll get this. So expanding this, you'll get n square plus 2n plus 1 minus 2b into n plus 1 plus an square plus bn. So this will give you an square plus 4an plus 4a plus bn plus 2b minus 2an square minus 4an minus 2a minus 2bn minus 2b plus an square plus bn. So now bn minus 2bn, this will get cancelled. Then an square, we have an square and minus 2an square, this gets cancelled. 4an minus 4an, then 4a minus 2a, so this will be just 2a, and 2b minus 2b will get cancelled, so it will be left with 2a. So from this you can find the value for a, which is nothing but 1 upon 2 delta square yn. Okay. Now if you substitute this equation in the one which we got, delta yn equals to 2an plus a plus b, that was equation 1. So substituting this value in this equation, you will get delta yn, which is equal to 2 into an. So now value of a is 1 upon 2 delta square yn into n, plus a is again 1 upon 2 delta square yn plus b. So keeping b on the one side, you will get delta yn, 2 will get cancelled, so we will be left with minus n into delta square yn minus half into delta square yn, which is equal to b. So now taking delta square yn common, you will get delta yn inside the bracket. You will get, then so b will be equal to 1 upon 2 delta y minus 1 upon 2 2n minus 1 upon 2 into delta square yn as your b. So you get the value of b and you have value of a. You substitute the value of a and b in the original equation. So it is yn equals to an square plus bn, right? So here substituting this value, half delta square yn into n square plus delta yn minus 2n minus 1 upon 2 into delta square yn into n. So solving this, you'll be left with 2 is common in the denominator. You can convert into 2yn, which is equal to n square into delta square yn plus, now this 2yn, so this will be 2n into delta yn minus n into 2n plus 1 delta square yn. Okay, so now taking delta square n common from this and this, you will get n square minus 2n plus 1 into n into delta square yn plus 2n into delta yn minus 2yn equals to 0. So n square plus n into delta square yn minus 2n into delta yn plus 2yn equals to 0. So solving this, you will be having n into n plus 1 delta square yn minus 2n delta yn plus 2yn equals to 0. This is the required thing. So now, as you have seen, there are two methods. The first one, determinant one, you can use that when n is in the power position, and if it is as the coefficient or something as in this, then you can solve it with delta method.